So now you know what is Bloc and Cubit and what are their components, and also how to use them in a simple application. And in this section, we will be using first the Bloc and then the Cubit to separate the business logic from the UI code in the library where we code the Firebase CRUD, or create, read, update and delete, and that is the library of the 17th section in here. So after using both the Bloc and the Cubit this way in the Firebase CRUD library to separate the business logic from the UI code, all of your confusions about them will be eliminated one by one. So first of all, initially on our emulator we have a simple scaffold. So first of all, to separate the business logic from the UI code of this Firebase CRUD, what we have to do in here, simply copy the build method of this library and go to the main.dart and simply paste it in here and simply import the Cloud Firestore package, and there you go. Now after this, simply how to start your application. So that was a simple application of Firebase CRUD which we have created in the 17th section. So here we can create the data, and you can see we can get the data from the Cloud Firestore. We can also perform the update operation. We can also perform the delete operation, and this no data means we are also getting the data. So if there is no data in the Cloud Firestore, it is simply saying there is no data. And if you click this create, so simply one user is created in the Cloud Firestore and simply it get the data from the Cloud Firestore. Now first of all, in here what we will do, first of all separate this user model. So before this, here we want one more directory where we are gonna have our block for this Firebase CRUD. So in here we will simply create the directory for the block. So we will name it 19 block section 2. This is the 19th section of the week 2 and the section 2 for the block. So inside this we will create a new directory and we will simply name it model, and inside this model we will create one Dart file. Its name will be user model, and inside this user model simply paste this user model in here and simply import this Cloud Firestore package in here, and simply here delete this from here. So that was it for this. Now next thing, inside this we are going to have one more directory inside this block section 2. We will create a directory. Its name will be database. Inside this we will create the Dart file. Its name will be database handler. Inside this we are going to have one class and its name will be database handler. So after this, simply go to your main.dart and copy all of these methods from here and go to your database handler and paste it inside the class and import the Cloud Firestore package in here, and also import the user model in here, and also remove the underscore before them and simply put the static in front of the methods so that we can access them directly from this database handler class. So one by one remove this underscore and keep putting the static in front of them. So after this done, we have successfully separated the methods also from the main.dart, and now here we need to create the block. So before going forward for creating the block, you need to understand one thing, that is the value equality in Dart. So there can be some scenarios where we would want to compare the instances of the same classes like we do in test expectations in the stream transformations. However, different instances of the same class cannot be equal in Dart. If you don't believe me, let's go to the IntelliJ IDE to test it. So I am on the IntelliJ IDE where we have the Dart code and we have a simple main method, and here we have the class of the student. We have the two fields, and also these two fields are not initialized and simply are passed in the constructor. And in here in the main method, what we are doing, we have simply created the instance of the student class and its name is John, and inside this we have initialized the first property of the student class, that is name, and his age is 20. And inside the print statement we are comparing the two instances of the same classes. Like this is the first instance which contain the values of John and 20, and inside this we are doing John equal to the other instance of the same class which contains the same values of John and 20. So what do you think? it will return true or false. Obviously, it will return false in Dart. So now when I run this and we got the false, the two instances of the same values are not equal in Dart. So how we can overcome this? To overcome this, we have two methods in the class that we need to override. So these methods are the equality operator and the hash code. So we need to override these methods to compare the values of two different instances of the same class and then simply give us the result. So in this operator method, it is comparing the runtime type, the name and the age with the other instance, and here in the hash code, it is also comparing the name hash code and the age hash code. So after having these two methods inside the class, if we now run this, so we got it true in here. So now this instance of the class is equal to this instance of the class just because these have the two same values. But if we don't have these two methods, so this will simply do not compare the values and simply by default the two instances of the same class will be different or will not be equal in Dart. So same like this in our blocks, events and stat classes. If we ignore these overrides or shortly the value equality, the stream of stat listeners like the block builder will rebuild the UI each time even if the values are same in the old and the newly emitted stat, because again the different instances of the same class cannot be equal in Dart. As a result, the block builder will rebuild the UI with the same stat considering it the new stat. So for overcoming that, we need to do this equality operator and the hash code in each class we want the value equality, which is kind of so much hassle. So to also overcome this boilerplate code for value equality in each of the class, we have the equatable package. It's a Dart package that helps us to implement the value-based equality without needing to explicitly override the equality operator and the hash code. So simply we will remove these two methods from here and simply we will extend this student class with the equatable, and it is coming from the equatable package, and you must have this equatable package in your pubspec.yaml file. So after extending this student class with the equatable, which is an abstract class used for the value equality, simply here we need to override one getter method. So here simply remove the to implement props from here and this accept the list of objects, simply pass the list in here and pass the name in here and also the age in here, and that's only it you need to do for the value equality to compare the instances, the two different instances of the same class. So for that we don't need to write the explicit equality operator and the hash code, and this is done by this equatable package internally. So after this done, if I run this, and this will still give us a true, meaning that we have overcome the issue of the Dart that two different instances of the same class cannot be equal, and also we have done this with the less code using this equatable package. And this equatable package can help us to improve the quality and the maintainability of the Flutter code by providing a simple way to define and compare the values of the objects. So with these two overrides in the class of the stat and events, or simply extending these classes with the equatable, later if the stream is notified with the same stat containing the same values, so it will not rebuild the UI. So just like this, we have overcome this issue. By using the equatable package, we have also reduced our boilerplate code just like this. So that was it you need to know about the value equality in Dart. So now move to the Android Studio and leave all the errors here just like this in the main.dart. So after this, we are going to create the block for our Firebase CRUD. So inside this 19 section block section 2 directory, we will create one directory and its name will be block. And inside this block directory, we will create one more directory, its name will be Firebase CRUD, and simply create the block class in here and make sure you select the equatable in here. So we will use this for the value equality to compare the different instances of the same class, so that later if the stream is notified with the same stat containing the same values, it will not rebuild the UI. Otherwise, if we don't have any value equality operators or the equatable package, it will rebuild the UI even if the newly emitted stat contains the same value. So here we will name our block Firebase CRUD and hit the enter, and we got these 3 Dart files in here. And make sure in the pubspec.yaml file you must have this equatable package, otherwise you will get these errors just like I got in here. It will simply say the equatable is not in here, and it is saying the classes can only extend the other classes just because we don't have the equatable package in here. So after adding this, simply pubget, and after this pubget completes, all the errors will be fixed. So you can see the pubget completes and also the errors are fixed. Now let's go for the stat and ignore this pubspec has been edited package. So we have the Firebase CRUD stat which extends the equatable, and here we are going to have the different stats of our Firebase CRUD simple application. So you can see we have already got the direct override method where we can directly pass our properties of the class for the value equality, and this will simply done the equality work like the equality operator and the hash code for us. So in this app we are going to have some specific stats to deal with, as we are going to read the data from the Cloud Firestore, so we need to retrieve it. So what will happen or which stat it would be if the data is loading or retrieving from the Cloud Firestore, or which stat it would be if some failure occurs, or also which stat it would be if the data is loaded. So we are going to have 3 different stats of loading, loaded and the failure. So in here we will simply copy this initial stat and will paste in here 3 times, and you will change the first name to loading and the second to loaded and the third to failure. And the Firebase CRUD loaded stat is going to hold the list of user model in the constructor, because when this stat is imaged on some event in the block, this will accept the list of user as a parameters. So we will simply pass the list of users that are gotten when the stream was listened, and then later on the UI we will map this list, and for each of the user we will display some specific item, and all the users will be in the scrollable view on the emulator like you can see in here for now. Just like this, we will simply create a list style item for each of the user later on. So now in here, simply pass this in the constructor and also in here for the value equality. So that will be it for the stats of this Firebase CRUD, and now we are going to implement the events for the Firebase CRUD. So we are going to have the events or the action that will be triggered on the UI. The first action or the event will be like we are going to have the create data event, and we are also going to have the delete data event and also the update data event and also to get the data event. So we are going to have these 4 events in place. So here we are going to have a class and its name will be create data event, and this will extend the Firebase CRUD event and simply open the body for the class, and here it is going to have one missing override that will be of the value equality prop. So after this, simply copy this create data event and paste it 3 more times just like this, and simply change their names to read, update and delete just like this. So when the create data event is triggered, we are going to create the user in the Cloud Firestore. So this is going to accept in the parameters the user model and also pass it in the constructor, and also for the value equality pass it in the list just like this, and simply copy this body of the create data event from here and simply paste it for the update data and also for the delete data, as we are going to update the user and also to delete the user. And now it's time to explore the read data event. So we are going to have the 2 events for reading the data from the Cloud Firestore. Like let's copy it and paste it in here and simply change its name to load data event. So the first one, the read data event, will only be for listening to the stream, and the other, the load data event, will be for emitting the loaded stat to show up the data from the Cloud Firestore on the UI. And the first one is not going to hold any data in the constructor because it is just for listening to the stream of the users, and the second one is going to hold the list of users in the constructor because it will emit the load stat of the list of users to show up all the users on the UI, and simply finally pass these users in the constructor and simply also pass it in the list of props for the value equality. So why we are going to have the two events for reading the data? That is because when the block stat stream is first listened to, like when the read data event is triggered for fetching the data from the Cloud Firestore, the UI may be in the indeterminate state, like showing the loading indicator, for example. Triggering an additional event to emit the loaded state allows the UI to immediately display the loaded data and remove the loading indicator. This provides a better user experience as the user don't have to wait for the state to change to see the actual data. So while dealing with streams and block, one event will be for listening to the stream and the other will be to load the loaded state to show up the data on the UI. For the other future methods like create, update and delete, we need the user data to create, update and delete the user. So we simply pass the user directly in here, which contains the user data directly. So that will be our events, which will come to the block in the stream, and this will emit the streams of stats, and later that will be listened on the UI using the block builder or the block consumer widgets to update the UI over the time. So that was also it for the events of the Firebase CRUD simple application. So now we are going to implement the block of our Firebase CRUD. So here we are going to have all the events as we had for the counter. So in this case we have about 5 events in place. So simply we will do just like this. So we got read data event, load data event, create data event, update and also delete data event. So now what will happen if the read data event is triggered? So first of all we will put the try catch block, and if some error occurs we will simply emit the stat for the Firebase CRUD failure. And in the try block we will do, first of all we will simply emit the Firebase CRUD loading stat for showing the loading indicator if the stream is listening, and that's it. After this we will create a final variable. Its name will be stream response, and this will be equals to, from the database handler class we will simply access the read data method, which is for in here reading the data or the users from the Cloud Firestore in the stream. It gives us the stream list of users. So in the block after this we will do stream response, which has the high order functions and give us the list of users just like this, and inside the body of this we will dispatch the event or trigger the event of load data event, which accepts the list of users, and later this load data event will also be implemented. First of all here we simply call this event in here and pass the list of users. So this load data event will simply emit the loaded stat and will show up the data on the UI. So that was not it for the read data method. We are going to have one more thing, that will be a simple variable of stream subscription list of users, and its name will be user stream subscription. And after this we will simply copy this, and here we will paste it and we will make this equal to stream response just like this. So by subscribing to the stream in the block, the UI can be notified whenever the new data becomes available, and it allows it to refresh and display the updated information on the UI. And also before subscribing to the stream we need to call the stream subscription.cancel, and also the override method of the close inside the Firebase block to close the stream just like this. So closing a stream subscription before listening to the stream is typically done to prevent the memory leaks. The stream subscription maintains a connection to the stream, so if it's not closed, the connection remains open even when the stream is no longer being used. This can result in resources being held indefinitely and leading to the memory leaks. Closing the streams before listening to the stream ensure that the connection is closed when it's no longer needed, freeing up the resources and preventing memory leaks. So that's why we are closing the stream before listening to it. So that was it for the read data event, and now let's go for this load data event, which is going to emit the loaded stat. So first of all in here we will put the try catch block, and if some failure occur we will simply emit the Firebase CRUD failure, and in the try block we will emit the Firebase CRUD loaded stat to update the UI, and we will simply pass the event.users that is coming from when this stream is listened in the read data event. So when this read data event is triggered, simply this will dispatch or trigger this event also to update the UI and fetch the users and display them on the UI. So that was it for this load data event and also the read data event. Now let's go for the create data event. So what will happen if the create data event is triggered on the UI? First of all, here we will do the same try and catch if some failure occur. Inside the try block, we will check if the state is Firebase CRUD loaded, meaning that if there is data on the UI, so then we will be able to create the data. Otherwise, we will not be allowed to trigger this event. So we will first check if the Firebase CRUD is loaded by this load data event. So inside this, we will perform the operation that will be the database handler create data method and pass the user from the event.user. And that was it for the create data method. Now simply copy this try catch from here and paste it also for the update, and simply change this create to update data event, and this will everything will remain the same. And also the same for the delete data, simply call the delete data event, and in the delete data event we are not going to have the complete user, but there will be a simple string of ID, and pass this in here, also in here. So in the block we will do simply pass the event.id. So that was it for the delete data event implementation in the block also. So we have implemented all of the events in the block, like what will happen if each of the event is triggered and what state it is going to emit first and last. So that was it for the block implementation. So now let's go and utilize them in the UI. So now on the main.dart, let's go for utilizing these methods on the UI. Here, first of all, we need to provide the Firebase CRUD block so that it will be available to all its content widgets context, so that will be easy for us to use it from every context of a widget, even if it's stateless or stateful. So we'll copy this block provider and simply paste it and change its name to Firebase CRUD block. And whenever this block is provided, initially we will simply directly add an event that will be of read data event, so that will directly listen to the stream and will update the UI on the load data event when the app is first initialized. So like when the app is first initialized, we will call this read data event. So first our users will be show up in here, so that we will be allowed to perform the create, update and delete operations. So that's it for the provider and invoking this event initially in here. So now go down here, and here we will do, first of all, for this create data, we will remove this from here, and we are going to have the block provider dot of context, and in the context we already have the Firebase CRUD block. So as a type we will pass the Firebase CRUD block, and from this we will dispatch or trigger an event by doing this add. This will be create data event which accepts the model of the user, so you'll pass the user, instantiate it, and for the email this will be, let's say, john@gmail.com, and the username will be John Doe, and the ID will be randomly generated in the create method. So that was it for the create method. Now let's copy this. Now let's go for reading the data. So simply leave everything as it is and copy this padding widget from here. Cut this, or not copy it but cut this from here, and we are not going to need the stream builder anymore, but we will use our block builder in here to listen to the newly emitted stats in the stream. So we are going to have a block builder, and this is going to return the same widget which we have cut from here. So for now let's close it and change this subject to Firebase CRUD block, and also copy its name and paste it in here, Firebase CRUD stat. And now here we will check the conditions. If the stat is loading, simply in the body we will return in the center, and in the child of the center we will do circular progress indicator. When the stat is loading, simply we will show up the circular progress indicator, and copy this if condition from here, paste it right here, and change this Firebase loading to the failure. So if the stat is failure, we will remove this circular progress indicator, put some text, and we will say something went wrong, and then we will check the condition if the stat is loaded, simply we will return this padding widget in here, and in this return we will simply directly return the center child circular progress indicator. Now in this Firebase CRUD loaded stat, we will create a final variable. Its name will be user and will be equals to the stat.users, which is coming from here these users. So when in the block, if the read data method event is triggered, so here it will listen to the stream and this will give us the list of users. So you're passing them in the load data event in here, and simply this will emit the loaded stat to show up the data on the UI. So when the loaded stat is emitted, so it means we have got all of the users. So after this we have stored them in this final variable and simply we have mapped them in here, and for each of the user we are showing their name and email. And now it's time for this update and delete. So the same will be for them. Copy this block provider and paste it in here, and this is not going to accept the user, but this will be a simple user.id and it will be delete data event. And remove this direct method from here and simply again copy this and paste it in here, and change this to update, and also as the ID pass the user.id, as we are going to update the specific user on the unique ID, and this will update the user to simply, let's say, 3xa@gmail.com, and its name will also be 4xa. So that was it also for the methods on the UI, and also we have removed the stream builder and we simply put the block builder to listen to the stream of stats. Now after this, how to restart your application. So everything will remain the same. Now when we click this delete, it simply directly delete the data from here, and we are no more seeing the no data in here. That is because here we can check if the users dot is empty. Simply show up in the center child text no data. That's it. Otherwise show up the padding, that is the users in here. Now after this, simply Ctrl S to hot reload, and we got the no data in here as the list of users is empty. And now when we create this create the join.user, the data we have passed in here, and we can update it just like this, and it is also reading it. You can see on the UI. We can delete it, there is saying no data, we can create it, we can update it, and we are also reading it. With the block, we have implemented the block in here, the events and the stats, and you have also seen how we can work with a bit complex application using the block. So that was it for the block with the Firebase CRUD simple application, and in the next section we will also do it in the Cubit, so the Cubit will also become more clear to you. So for now, that was it for this section. So up until now, you learned how we can work with Bloc and Cubit in a simple application, and also with this, you learned how we can work with Bloc in a bit complex application like the one in which we are dealing with the CRUD operations of Firebase Cloud Firestore. And now in this section, we are going to learn how we can use the Cubit instead of the Bloc in the same application of Firebase CRUD. So first of all, in here, in the 19th section of week 2 and in the section 2 of Bloc, simply inside this, let's create one directory and name it Cubit. And inside this Cubit directory, create the directory of the Firebase CRUD as we have the one for the inside the Bloc directory. So let's do it the same. Create the directory, and inside this Firebase CRUD directory, create a Cubit class, and make sure you select the equatable, and also you must have one package or dependency in your pubspec.yaml file before using the equatable with the Bloc or Cubit. So I will name my Cubit Firebase CRUDs. The CRUDs is because if we create the Cubit with the same name as we have in the Bloc, so the stat name of the Bloc and the Cubit will be same, so this might create some ambiguity between the Bloc and the Cubit. So that is why I am naming the Firebase CRUDs, or you can name it anything you want to your Cubit of Firebase CRUD. So let's click the OK. So two libraries will be created, one the stat and the Cubit. So let's go for the stat, and we know that simply copy this and paste it 3 times, as we are going to have the loading, loaded and the failure. So simply for this we are going to have loading, and for this we are going to have loaded, and also for the last one we are going to have the failure. And inside this loaded stat we are going to accept the list of users to show them on the UI. So we will go for the block stat, and inside this we will simply copy this data from the loaded stat, and inside this we will paste it right away, and simply change the constructor name and also import the model of user. And that's it for the stat in the Cubit. Now let's go to the Cubit, and inside this we are going to have the 4 methods as we had the events in the block. So first method will be of type void, just like this, and its name will be read data. So let's open the body for it, and first of all we will put the try catch inside this. So we got the try catch inside the read data method, and if some error occurs in the catch block, simply this will emit the Firebase CRUD's failure stat. So now inside the try block we are going to do, first of all, emit loading stat as we had in the block for reading the data. Here first of all we are emitting the loaded stat, and next we are going to call the same read data method inside the stream response variable. So simply copy this from here and paste it in here. So that will be our second thing inside the read data method. So after the stream response variable we need one more thing that is also in the Firebase CRUD block, and inside this we will simply copy this stream response in here, and we don't need this user stream subscription in the Cubit. So we'll simply paste this right here, and we also don't need this event in here. So we will simply emit one stat, and that will be Firebase CRUD's loaded, and simply pass the users in here. And in here let's remove this user from here to make the error fix. So that was it for the read data method. First this will emit loading stat, and inside the stream response this will call this read data method. So this will give us a stream of list of users. So simply we'll listen this stream, and this will give us the list of users that are listened in the stream, and simply we'll pass them in the loaded stat, and that stat will be emitted on the UI to show the data on the UI. So that's it for the read data method. And next we are going to have the methods for the create, update and delete. So next method will also be of type void, and its name will be create data, and this is going to accept the user, as this is going to create the user in the Cloud Firestore. So inside this we will check if the stat is Firebase CRUD loaded. Simply from the database handler simply call it create data method and pass the user in here. So that's it for this. Now copy this and paste it 2 times, as the 2 other methods are going to be similar to this, and change this name to update data and this to delete data. And this is going to accept the string ID, and this method will be update data, and this will be delete data, and pass the ID in here. So that was it for the 3 methods also: delete data, update data, create and also read the data. So you can see the Cubit reduced a lot of boilerplate code. We don't have the events, but all of the work is managed by the Cubit. And next, after implementing this Cubit, next go to your main.dart, and we know that we need to provide the Cubit just like we have provided all the others, Bloc and Cubit. So simply we will copy this block provider and paste it right here, and change its name to Firebase CRUD's Cubit. Also import this and remove this event from here, and simply call the method of read data. So that's it. Now remove this useless bracket from here. So we are good to go. We have provided the Cubit in here. Now what we need to do in here, simply change the methods in here. So we'll simply copy this and paste it right here, and comment this block from here, and now we are going to use the Cubit instead of block, and this will be CRUD's, and it's already imported. Now instead of calling the add method, we will directly call the create data method, and inside this we will pass the same user model object and also the same data of John, email and username of John Doe. Next, we only need to change the block builder here, so it will be the Cubit and it will be CRUDs, and here the stat will also be Firebase CRUD stat. So that's it. Now here this will be Firebase CRUDs loading and Firebase CRUDs failure, Firebase CRUDs loaded, and everything will remain the same. Now next we need to change this to the Firebase CRUDs Cubit, and instead of this event simply call the direct method in here, just like this, which makes it really simple than the block. And next here the same will go for this update method. Simply change this to Firebase CRUDs Cubit just like this, and replace this whole add method of triggering the event with a simple method of the Cubit. So we got the update data method inside, we got the same user object with the same data as we had for the previous block. So that was it also for this. Now after this, simply hot restart your application and you are good to go. Now we have successfully implemented the Cubit. You can see here we have the provided Cubit and we have changed this to Cubit. Also this block builder to the Cubit, and also its stat, its loading, failure, and also the loaded. And also we have changed these two methods of Firebase Cubit, delete data and update data, and also this one to create the data. Now next, if we click this create, this will the same create the data, we can update it, we can delete it, and it is also getting just like this we are seeing on the UI. So that was a simple Cubit for a same simple app of Firebase CRUD, and that's how we deal with the Cubit in a bit complex application. And this will become more clear to you when we go forward and start building the real-time application of this bootcamp. So that's it for this section, and see you in the next section.